Hello guys, welcome back to the Math UMS class. And today we will have a new topic of polygons. I believe that you have learned something about this in the ordinary math class, but I will try to introduce to you something new and something interesting in this lesson. And again, I think that you'll be glad to meet an old friend. Okay, let's the lesson begin. First, about the name polygons. It is made of two parts. The first part is poly, which means new in Vietnamese, and the second part is gon, which means angle, or it means góc in Vietnamese. So polygon, nhiều góc. In Vietnamese, we call it đa giác. So polygon means đa giác. But what are polygons to be precise? Now let's come to the definition. And again, the cat and the dog will accompany us in the lesson today. Okay, hello, welcome back. So this is the expertise of the cat. So the cat will be the leader today instead of the dog as in the previous lesson. Okay, the cat is going to give us the definition of a polygon. A polygon is a closed plane 2D shape with straight sides. So there are three key words here: closed, plane, or 2D, and straight sides. Okay, how? Definition. Show some examples, please. Okay, all of these are polygons. Here, the rectangle, which is familiar, the triangle here, and here are two other polygons. You can see that they satisfy all the three criteria. The first is they are all closed, they are all plane or 2D shapes, and they all have only straight sides. And the dog asks, what shapes are not polygon? And the following are not polygon. You can see that in the first shape, it is not polygon because it has a curved side. It has a curved shape. It is not made of straight sides. And in the second shape, it is not closed, hence it's not a polygon. In the third, it also has a curved part, and that makes it not a polygon. And for the third one, it is not a plane shape, so it is not a polygon either. So I hope that you, just like the dog, can now tell exactly if a shape is a polygon or not. Alright, let's examine further about the polygons. First, we will go to the anatomy of a polygon, which means we will try to study the parts of a polygon. You can see that these are sides of a polygon, very familiar with you, right? And these are the vertices. You know that vertex is a singular form and the plural form of that is vertices. Here we have a lot of angles. Polygon means many angles, right? So we have a lot of angles. Here are two interior angles. Of course, this shape has 1, 2, 3, 4, 5 interior angles. And they also have exterior angle, which means the angle that is on the exterior of that shape. Can you see that? Exterior angle. And a polygon of n sides has exactly n vertices and is written as n gon in the general form. Like when you want to talk about a polygon in general, but you don't want to specify the number of the number of vertices that the figure has, you can call it n-gon. It means the polygon of n sides. So n-gon means the n-sided polygon. Just like 3-gon is a three-sided polygon, which is a very familiar shape. Okay, now let's test the memory. And you should pause this video and try to remember all the parts of this polygon here, and then you can continue with the video and see whether you have all the boxes filled with the correct words. The dog says that he can name them all. Can you? Okay, in the first box, these are interior angles, and these are the sides of the polygon. Next, we have the exterior angle. You can see here, this region is the exterior angle. And here are the vertices. Okay, have you got all the boxes filled right? Good. Now let's move on. Amazing, good job, Doug. Now we will continue with the classification of polygons. Polygons can be divided into two major classes, convex and concave. So what are convex polygons? Here are some examples of convex polygons. And here are some examples of concave polygons. Can you see the difference? And can you name the characteristics that make them convex polygons and concave polygons? Okay, now the cat and the dog will show you. Here, the convex polygons, you can see that all angles point outwards. You see that all the angles point outwards. But in the concave polygons, you can see that some angle points inwards. Just like here, this angle here, it points inwards. And this angle here also points inwards. So this is an example of concave polygon. Can you see that? I think you can see, you can look at a polygon and tell immediately whether it is convex or concave just by like the visual of each polygon. All right. In mathematics, we will consider convex polygons much more often. So from now till the end of this chapter, we will discuss only convex polygons. Hence, polygons in this chapter is interpreted as convex polygon. So if I don't say specific, particularly that these are concave polygon, and when I just say polygon, you can understand that I am referring to the convex polygon. Okay? So sad to have to say goodbye to the concave polygons for now. Hope to see you again in the future. Alright, but the dog says that there are many shapes that are polygons. Do they have names? Sure bean. Alright, so the cat knows that there are a lot of names for different types of polygons. Let him show us what are the names of the polygons. Polygons with fewer sides are common and have special names. And the cat says, let's see how polygons are named. The dog thinks that they are named according to how many sides they have. The cat agrees. So the polygons are named after the number of sides that it has. Here we begin with the most familiar polygon, the triangle. 3 sides, 3 vertices, and 3 angles. Polygons which have three sides are called triangles. Next, we have quadrilateral, four sides, four vertices, and four angles. Next, we have pentagon, five sides, five vertices, and five angles. Hexagon, six sides, six vertices, and six angles. And the case is that triangle has three angles. The tri means three. I don't know whether it is Latin or Greek, but it is three. And similarly, quad means four, penta means five, hexa means six. That's how the polygons are named, based on the number of sides that they have. And we can expand the list to many more polygons, but this is a list of the first, uh, the most common and polygons. We have three-sided triangle already known, four-sided quadrilateral, five-sided pentagon, six-sided hexagon, and now we have seven-sided heptagon. Eight-sided polygon is called an octagon. Nine-sided is nonagon. 10-sided is decagon. The dot suggests taking a screenshot of this to save the list of polygons. Okay, that is the first pass. Now we are going to the second part of this lesson, the number of diagonals in a polygon. First, let's consider some simple polygons and find how many diagonals each of them has. First, triangle with three vertices. Second, we have quadrilateral with four vertices, pentagon with five vertices, and hexagon with six vertices. In the triangle, you can see that there is no diagonal at all. There is no diagonal. When you connect one point to another point in a triangle, we have the side, not the diagonal. In the quadrilateral, we can see that there are two diagonals here in the quadrilateral. How about a pentagon? We have 1, 2, 3, 4, and 5 diagonals. 5 vertices, 5 sides, 5 diagonals. How about a hexagon? A hexagon has 9 diagonals. Unfortunately, it doesn't have 6 diagonals like the pentagon have 5 diagonals. But now here is the sequence of first polygons. Can you see the pattern? 0, 2, 5, 9. When you recognize the pattern, you can continue the pattern to see how many diagonals does a seven-sided polygon have. Do you recognize the pattern? Oh, the dog knows the pattern now. How about you? Do you recognize the pattern now? The next polygon in the list is the heptagon, which has 7 vertices. Now let's look at the pattern, the sequence of the diagonals. First, we have 0 diagonals. Next is 2 diagonals. You can see that the number of diagonals increased by 2. And then we have 5. That means that the number increases by 3. Next is 9, and the number increases by 4. So if we continue the pattern, we expect the heptagon to have 5 plus 9, which is 14 diagonals. Now let's see whether the heptagon has exactly 14 diagonals. It does. If you pause this video and you can count all the diagonals, you can see that a heptagon has actually 14 diagonals. Okay, good job, the dog. So the dog knows the pattern now and he can calculate number of diagonals. But he thinks that that is so inconvenient to calculate the number of diagonals in like bigger polygons. The polygons which have more size and more vertices, because it is hard to make a very long sequence to reach to that number of vertices. So is there any other way to calculate them faster? Okay, the cat said, most certainly. I will show you in the next slide. Okay, the cat is very smart. So the question is, how many diagonals does an n-gon have? So we will examine a general n-sided gon. But for the visual purpose, I will take the heptagon as a visual example. Okay, the first question we should think of is, how many diagonals can be drawn from a vertex A? So the dog answers the n minus 3 diagonals. So in an n-gon, we can draw n minus 3 diagonals from each vertex A. You can see that in the heptagon, we have 7 vertices, so we can draw 7 minus 3 equals 4 diagonals from a vertex, like A. But why minus 3, not minus 2 or minus 1? Because we have 3 vertices which don't make any diagonals. They are vertex A itself. You can connect A to itself to create any diagonal, right? And 2 neighbors, which means the 2 adjacent points to the vertex A. If you connect A to an adjacent point, you will have a side instead of a diagonal. You see that? So for an n-gon from a vertex A, you can draw n minus 3 diagonals. Do you all agree? If we have 12 vertices, then from each point of that polygon, we can draw 12 minus 3 equals 9 diagonals from each of the vertices. And if we're doing the same with all n vertices, then we will have n times, then we will have n times n minus 3 diagonals. See that we are doing the same with all n vertices. So the number of diagonals should be n times n minus 3 diagonals altogether. And the answer is n times n minus 3. But it is wrong. The cat claimed that that is wrong. So what is the problem? Let's try this formula to the heptagon, which is already known. If we use the formula, the number of diagonals in a heptagon should be 7 times 4 equals 28. But we know in advance that there are exactly 14 diagonals in a heptagon. So this formula doesn't work for the heptagon. It means it is wrong. So what is wrong? What is the problem? Can you think of it? Okay, the cat says that this way each diagonal is counted twice. So the dog realizes the problem now. The diagonal DA is still the diagonal AD. Here, AD, you can see that when we connect the point from DA, we will repeat a diagonal which is already drawn when we begin from the point A to the point D. Similar with all the other diagonals. Each diagonal is counted twice. So we should fix the problem by dividing the number by 2 to get the official answer. That's great, right? So the number of diagonals in n-sided polygon is n times n minus 3, all divided by 2. And now let's check with the heptagon. We know in advance that the number of diagonals should be 14. Let's try this formula to see whether it gives the correct answer of 14. The actual number of polygon diagonals in a heptagon is 7 times 4 divided by 2 is 14. Here 4 is nothing but 7 minus 3. So the formula works. It means that it should work for any other polygons. Remember this formula. It is very important. Yay, it is correct. Now let's have some bit of practice. How many diagonals are there in a 12-sided polygon? This one is no longer a hard problem. I know the answer right away. How about you? Do you have the answer? The number of diagonals in a 12-sided polygon is 12 minus 3 times 12, all divided by 2 equals 12 times 9 divided by 2 equals 54. That is correct. So the dog is learning so well, and I hope that UMS are doing well also, I guess. Yeah, the dog believes in you. Any more question before we end the lesson? If you have any question, you can type in the comment below this video, or you can inbox me, the teacher, Mr. Hui, anytime. You are all welcome. And here is the homework. The first task is to review the lesson. Memorize the concepts of polygons, convex and concave polygons, and names of common polygons. And you should practice calculating number of diagonals. And last but not least, complete the online quiz. And uh, I'm very thankful for the cat and the dog to join the lesson and help me a lot accompanying the lesson. And the student love the cat and the dog too. But next time, the cat and the dog won't be joining the class. So who do you want to invite? If you have a character that you want to be included in the next lesson, you can type it in the chat. I will consider some options and maybe I will make them appear in the lesson in next or next week or some class in the future. Alright, that is the end of the lesson. I hope you enjoyed it. Remember to complete the quiz test. Uh, you can find the link to the quiz in the comment section below. Okay, have a nice day. Goodbye and see you next week.